Hi everyone. Now we are going to see the next important hybridization, that is sp3 hybridization. sp3 hybridization. So the third important hybridization. Okay, next two more are there that we'll see in the next classes. That is the sp3d and sp3d2. Okay. Now first we'll go with the sp3d hybridization. sp3d hybridization. Okay. So this type of hybridization will get by the intermixing of one s orbital, one s orbital, and three p orbitals. Three p orbitals. P orbitals. So by that you will get a four equivalent, sp3 hybrid orbitals. Hybrid orbitals. Okay. So by that you will get a four equivalent sp3 hybrid orbitals. They are equal in energy, plus they are equal in shape. Equal in shape. Okay. We'll get a we'll get a four equivalent sp3 hybrid orbitals. Okay. So these four equivalent hybrid orbitals, so they will orient around the central atom with an angle of 109 degree 28 minutes. So by that, the molecule will possess a tetrahedral structure. Okay. Now, so here we have a so by that this hybridization will get a four equivalent sp3 hybrid orbitals. Okay. So each sp3 hybrid orbital consists of 25% s character, s character, and 75% p character. P character. Okay. So this the hybrid orbitals. Okay. By that, so because of that, so each sp3 hybrid orbital will consist 25% s character and 75% p character. P character. Okay. So I'll explain this sp3 hybridization by taking one small example, that is methane. Okay. This is a methane molecule. Okay. Now, so by taking this methane molecule, I will explain the sp3 hybridization. Okay. So in this, the central atom is carbon. Carbon is the central atom, and four hydrogens will act as a surrounding atoms. Surrounding atom. Okay. Now, you will see the electronic configuration of the central atom. Atomic number 6 to the carbon. Okay. You will see its ground state electronic configuration, that is 1s2, 2s2, 2p2. Okay. With the ground state electronic configuration. Ground state electronic configuration. Electronic configuration. Okay. So in the excited state, what happened? One electron from the 2s orbital is promoted to the 2p orbital. Okay. So we'll get a excited state. If you see the excited state electronic configuration. Electronic configuration. Okay. So one of electron is promoted to the 2p orbital. By that we'll get a 1s2, 2s1, 2p3. Okay. So in the excited state electronic configuration, the covalence will be increased to 4. Okay. In the ground state, the covalence is 2. But in the excited state, the covalency of the carbon is 4. Covalence of the carbon is 4. Okay. Now, so you see like this. Okay. And so there is a one half electron unpaired electron into s orbital, and there is the 2px, 2py, the 2pz. They each have a 1 off-field electrons or unshared electron, unpaired electrons. Okay. Now the central atom with the central atom undergo hybridization, orbitals undergo hybridization. It is 2s orbital plus 2px orbital plus 2py orbital and 2pz orbitals. They involves in the hybridization will give a 4 equivalent sp3 hybrid orbitals. Okay. So these four sp3 hybrid orbitals, they have a equal energy, equal shape. But if you see the atomic orbital, they have a different, a small variation in the energy, but the shape will be different. Okay. So they have a different shapes. All are dumbbell shape only, but in the different axis. Okay. In different axis. Here in different axis. This is the x axis. This is y axis. This is z axis. Okay. But all they have a dumbbell shape. You can see the s orbital is a spherical shape. Okay. So these four will have a 1 electron. So these electrons redistributes in the sp3 orbitals. Okay. So here inverted carbon. So these four sp3 orbitals will orient around the central atom carbon. So they will orient around the central atom. Okay. So this one sp3 orbital, this one other sp3 orbital, the other sp3 orbital, the other sp3 orbital. Okay. So they will orient in angle of 109 degree, 28 minute. Okay. Now, so each have a one unpaired electron. Each have a one unpaired electron. One paired electron. Okay. Now, so and each sp3 hybrid orbital overlap with the s orbital of hydrogen. S orbital of hydrogen. If you see the surrounding atom with the hydrogen, okay, there is only one electron in the s orbital, one s orbital. Okay, so these four sp3 hybrid orbitals overlap with the s orbital of hydrogen, which is having one unpaired electron. So while overlapping, so electron will be paired up with opposite spin. So they will be overlap with this sp3 hybrid orbitals overlap with the s orbital of hydrogen. S orbital of hydrogen is hydrogen. Here one hydrogen, here one hydrogen. Okay. S orbital of hydrogen, electron pair up with the opposite spin. Okay. So this way we will get a methane molecule and central atom possessing sp3 hybridization. Okay. So all are the sigma bonds. So all are the carbon hydrogen sigma bonds. Okay. So the carbon. Okay. This one sigma bond, carbon hydrogen sigma bond. So each bond is so the sp is formed by the overlapping of sp3 and s overlapping. Okay. Here one hydrogen, all are sigma bonds. So with bond angle of 109 degree, 28 minutes. Okay. So here all are the bond pair electrons. Bond pair. Okay. So by the repulsion, they will possess to them an angle of 109 degree, 28 minutes. Okay. So with the geometry of tetrahedral geometry. Tetrahedral geometry. Okay. So always the molecule with the molecule of central atom, which have a sp3, suppose if it is a sp3 hybridization. So automatically the molecule possesses the tetrahedral geometry. Okay. If all are the bond pair electrons around the central atom, so they will possess a 109 degree 28 bond angle. Okay. So this is the sp3 hybridization. Okay. Now same way, I would like to explain other two more molecules which are possessing the same sp3 hybridization, but there is a small variation in their geometry and bond. The geometry is similar, but bond angle will be different. Okay, so that also we'll discuss now here. So ammonia molecule and water. So these two molecules also possess central atom possess same sp3 hybridization, but their geometry is distracted from the tetrahedral. Okay, we go. So now we'll see why the geometry is distracted from the tetrahedral. We'll see that one by one. Okay. Now, for that, I'm taking the ammonia molecule. Okay, first we'll see the ammonia. In the case of ammonia, why the geometry is distracted from the tetrahedral. Now, if you see the nitrogen, central atom is in the case of ammonia, the central atom is the nitrogen. If you see its electronic configuration, atomic number is the 9, 7 is the figure. So both molecule in the molecule of ammonia are the same in the molecule of water. Both atoms possess, both central atom possess sp3 hybridization. Okay, first I'll take one. Okay, in ammonia molecule. Okay, now, so the central atom have atomic number 7 is the, okay, now 1s2. So if you see the its electronic configuration, that is 1s2, 2p3. Okay, so 2 electron pair in the s orbital and unpaired electron, 3 unpaired electrons in the 2px, 2py, and 2pz orbitals. Okay, so all the, okay, now, so the central atom will undergo sp3 hybridization, okay, and four sp3 hybrid orbitals will orient around the nitrogen. They orient around the nitrogen like this. Okay, so each are the sp3 hybrid orbitals. These are all the sp3 hybrid orbitals. Okay, so out of 4, 1 sp3 hybrid orbital having a lone pair electron, remaining having 1 unpaired electron, unpaired electron. Okay, so this unpaired sp3 hybrid orbital overlap with the s orbital of hydrogen, and make a nitrogen hydrogen sigma bond. Okay, same way all the sp3 hybrid orbitals overlap with the s orbital of hydrogen. Okay, they will make a sigma bond. Okay, sigma bond. Okay, sigma bond. So you see here. So out of 4 sp3 hybrid orbitals, so one have a lone pair electron, remaining have a bond pair electrons. Bond pair. So there is one lone pair electron here. The lone pair. So remaining are the bond pair. Bond pair. Is also bond pair. Is also bond pair. So already we heard from the valence electron pair repulsion theory. So lone pair, bond pair, bond pair. Repulsion is more as compared to the bond pair. Okay. So due to that, you will see the more repulsion from the lone pair. You will see the more repulsion from the lone pair. Because of more repulsion from the lone pair, so instead of tetrahedral, the molecule will possess a distracted tetrahedral geometry. Okay, due to this, because of this one, because of the presence of the lone pair electrons. Okay, so the molecule will be distracted from the tetrahedral geometry, and bond angles will decrease to the less than. So in the tetrahedral case, we see the bond angle is 109 degree 28 minutes. Okay, instead of 109 degree 28 minutes, the molecule will possess a 107 degree. 107 degree. Why? So there is a due to presence of one lone electron. So due to presence of one lone electron on nitrogen, the molecule, you see the bond angle, that is 107 degree. 107 degree. Okay. The shape also distracted. The shape also distracted from the tetrahedral. Okay, not exactly tetrahedral. Okay, with the distracted. So distracted tetrahedral geometry. Okay. So this is not tetrahedral geometry. This is a distracted tetrahedral geometry. So distracted tetrahedral geometry. Okay. And this ammonia molecule possess trigonal pyramidal shape. Trigonal pyramidal shape. Pyramidal shape. Shape is the pyramidal shape. Trigonal pyramidal shape. But geometry the distracted tetrahedral geometry. The angle of 107 degrees. Okay. Same way, if you see in the case of water molecule, if you see in the case of water molecule, the central atom, oxygen. So central atom possesses the same sp3 hybridization. Okay. So if you see the oxygen's electronic configuration, it's atomic number 8. It is 1s2, 2s2, 2p2, 2p, 2p4 here. Okay. In the 2px, 2 electrons. In the 2pz, 2py, 1 electron. In the 2pz, 1 electron. Okay. So you see the two pair electrons, 2 lone electrons. You can see in the case of oxygen. Okay. So though it will possess a sp3 hybridization, central atom possesses sp3 hybridization, but you can see the 2 lone pair electrons. You can see the 2 lone pair electrons in the sp3 hybrid orbitals. Remaining two sp3 hybrid orbitals will consist of 1 unpaired electron. Will consist of one unpaired electron. Okay. So these unpaired electrons of sp3 hybrid orbitals overlap with the s orbital of hydrogen. Okay. The electron will be paired up. Okay. So this sp3 hybrid orbitals overlap with the s orbital of hydrogen. Okay. To give a sigma bond. Hydrogen, oxygen, sigma. Okay. So already we know lone pair repulsion is more compared to the lone pair bond pair. So due to presence of the 2 lone pair electrons, they will possess more repulsion. So because of the more repulsion from the lone pair, the molecule will be distracted from the tetrahedral geometry, and all bond angles will decrease to the 104 degree. 104 degrees. Instead of 109 degree, 109 degree 28 minutes, the bond angle reduces to the 104 degree. Okay. You can see the oxygen molecule. You can see the 2 sigma bonds with the hydrogen, and remaining 2 sp3 orbitals will consist of lone pair. Okay. So here you can see the bond angle of 104 degrees. 104 degrees. 104 degrees. Okay. So this is the way. So the though molecule is possessing the though in the molecule the central atom possessing the sp3 hybridization. So due to presence of the lone electrons, on the central atom, the tetrahedral geometry is distracted. So they'll give it a distracted tetrahedral geometry. Okay. So this is the reason why the molecule of ammonium, oxygen having the distracted tetrahedral geometry. Simple. So the ammonia in the central atom, the central atom hydrogen consists of 1 lone electron, 1 lone pair electron. Oxygen will consist of 2 lone pair electrons. Lone pair electron. Because of this lone pair electrons, the geometry will be distracted from the tetrahedral. Thank you. Have a nice day. In the next class, we'll see the sp3 dehybridization. Thank you. Have a nice day.